Hello, in this video we're going to be looking at a problem where we've got a 2023 by 2023 grid, and there's some number of beetles that are on the squares of the grid. So to simplify things, I'll just draw a 5 by 5 grid, but you can hopefully imagine what it would be like if it was bigger. So let's say these red dots are the beetles. So maybe we could have a beetle here. We'll put one here. Okay. So basically, what happens is that every move, like the beetles will all simultaneously move one square. So maybe this one will move over here, this one will move over here, and so on. And every time they move, they have to make a 90-degree turn. So this means if it's going up or down on one move, it has to go left or right the next move. And then the move after that, it's got to go back to up and down again. So it alternates. You could kind of say that the axis that it's moving along has to alternate every move, although you're allowed to start out along whichever axis you want. So maybe this one will go this way, this one will go this way. Maybe this one has to go this way. So this is one possibility for the first two moves. The question is, what is the minimum number of beetles where two beetles must eventually occupy the same square? So no matter what you do, no matter what the starting position is, and no matter what moves you make, you'll eventually end up with two beetles on the same square. Assuming you start out with that, that number of beetles. So the full proof for this is kind of hard to explain, but the answer is not 2023 squared plus 1 over 2. It's actually larger than that. So one thing you could do to try to see that is to simplify it to just looking at a 2 by 2 grid. You can actually put 4 beetles on this grid without ever having to have two in the same without having to ever have two in the same square. So I encourage you to just think about how to do that. And let's see, yeah, just think about how you could do that. And to prove to prove the upper bound, you'll want to color the tiles of the grid in a certain way. One example of a coloring, I don't think this will actually solve the problem, but you could start out by, coloring kind of like a chessboard, maybe, and you can notice that at every turn you have to move from, if you're on a white square, you have to move to a black square. If you're on a black square, you have to move to a white square. Although this doesn't quite capture all the information, because you're also told that every move you have to make a 90-degree turn. So if you're on this square, you can't end up at this square after 2 turns. It has to be this square. So thinking about what happens after 2 turns is going to be really helpful. And there's a way that you can color it in. There's a way that you could color it in that will actually help you to solve the problem. Well, anyway, those are just some hints. Let me know if you need any more help. Hello. I think the key idea for this problem is to focus on this specific coloring of the squares. So basically you've got 4 different colors. Here we've got red, orange, green, and blue. And we're coloring in 2 by 2 square, and then every 2 by 2 square sort of has the same arrangement. So you can kind of think of this as a new square of 2 by 2 squares, except they kind of get cut off at the edges on the right and on the bottom. Now, what's interesting about this coloring is that if you pick any particular color, if one of the beetles is on a square of that color, it must come back to that color after 4 moves. For example, let's say that you start on red. Doesn't matter which color, but let's say that you start on red, and then maybe the next move you go to orange. So you could go to orange or green, but it really doesn't matter. Okay, so you have to go to one of those. You can actually use without loss of generality here. Okay, in the next move you have to go to blue, no matter whether you turn right or left. This is also another without loss of generality moment. Okay, then no matter what you do, you have to go to green. So notice you're kind of forced, once you choose your initial direction, you're kind of forced in terms of where you're going to go in the next move. So when you go to green, then in the next move you have to go back to red. It doesn't matter what path that you choose, you're still going to have to end up going back to red. You could try also going the other way too, which I didn't quite draw, but it still ends up sending you back to red. So another way to see this is that every 2 moves, you have to move in one of these directions. So I guess after 4 moves, you'll either get back to where you started, or you'll be somewhere here. So I guess there's 5 different places that you can be after 4 moves, but they're all going to be the same colors where you started. So you can actually use this to decrease the upper bound for the possibility of how many there can be without them bumping into each other. So think about the blue ones. Okay, the blue squares, that's the one that there's the fewest amount of. There's 1011 squared blue squares. And we know that every 4 moves, oh yeah, this is actually true. Every 4 moves, you have to go to a blue square no matter what. So notice in this path, we started on a red square, but we ended up visiting squares of every color. It turns out that that's unavoidable. So every 4 moves, at some point in the first 4 moves, you're gonna end up on a blue square. Every 4 moves after that, you're gonna keep coming back to a blue square. So you could sort of divide all the beetles into 4 groups, depending on when they're in the blue square. So, if you assign a number to each move, some of them will be in the blue squares when the time is equal to 0 mod 4, 1 mod 4, 2 mod 4, 3 mod 4. So there can be at most 1,011 beetles in each category because that's how many squares there are. So there's a maximum of 1,011 squared in each group. So you're never allowed to have more than that. So the total maximum is going to be 2,022 squared. And you can achieve this number basically using the method from the previous video, I think. So you basically, for each of the 2 by 2 squares, you just have, you've got 4 beetles. This one goes here, this one goes here, this one goes here, and this one goes here. They just keep doing that sort of like rotation forever. And you can fill up this entire part of the grid besides the right column and the bottom row. So that's how you get the answer.